There are moments in mobility design when scale alone ceases to impress, and instead proportion becomes the dominant language of authority. What stands before us here is not simply large, it is deliberate, it is structurally assertive. It presents itself less as a recreational vehicle and more as a rolling architectural structure conceived for extreme autonomy. Before we proceed further, it is important to frame this correctly. What we are examining is a fictional, AI-generated luxury expedition motorhome concept created purely as a speculative design exercise. It does not exist in physical production form, nor is it intended to represent a purchasable product. However, from an analytical standpoint, it is engineered visually with such coherence that it invites a serious technical breakdown. And that is precisely how I will approach it. From a dimensional standpoint, this concept appears to occupy the upper threshold of expedition-class motorhomes. I would estimate an overall length in the range of 10.5 to 12 meters, with a width approaching 2.6 meters and a height that likely exceeds 3.8 meters, including the roof-mounted systems. The stance is upright but not top-heavy. That is critical. The multi-axle configuration, 3 driven rear axles paired with a forward steering axle, immediately suggests a heavy-duty ladder frame or reinforced monocoque hybrid chassis designed to manage extreme load distribution. This is not an aesthetic decision, it is a structural necessity. The wheelbase appears segmented, with relatively even spacing between the rear axles, which would serve to distribute static weight from the habitation module evenly across the chassis. From an engineering standpoint, such spacing reduces stress concentration on any single axle and enhances longitudinal stability over uneven terrain. The forward axle sits slightly more rearward than in conventional trucks of similar size. This positioning suggests a design intention to optimize approach angle and minimize front overhang intrusion during steep terrain entry. Ground clearance is substantial. Visually, we are likely looking at 400 to 450 millimeters beneath the lowest structural elements. Combined with the deep profile off-road tires and heavy-duty suspension arms, this vehicle appears designed for uncompromising off-grid capability. Now, what truly distinguishes this concept is its surface modeling. Rather than relying on smooth, flowing curvature typical of European luxury motor coaches, this design adopts an angular, faceted geometry reminiscent of armored aerospace craft. Each body panel transitions with purposeful chamfered edges. The surfaces do not merely connect, they intersect. This gives the vehicle a sense of structural rigidity even before discussing the internal frame. From an aerodynamic standpoint, one might initially assume such angularity increases drag. However, the controlled tapering along the roofline and the slightly rearward angled windshield mitigate frontal pressure buildup. The windshield rake is more aggressive than typical expedition trucks, reducing airflow stagnation and guiding wind toward the roof-mounted light bar housing. The side panels are largely vertical, yes, but notice the slight inward tuck beneath the window line. This slight sculpting reduces turbulent wake formation along the habitation box. At highway speeds, the drag coefficient would still be significant due to frontal area. However, for a vehicle of this mass and purpose, aerodynamic optimization is less about speed and more about crosswind stability, and the broad, squared shoulders would provide predictable airflow separation points. The matte black finish is particularly telling. This is not gloss automotive lacquer. It appears to be a ceramic-infused, low-reflectivity coating designed to minimize glare while offering abrasion resistance. On a vehicle intended for remote terrain exploration, matte surfaces reduce light reflection in desert or snow environments, which in turn reduces driver fatigue. The layered panel construction suggests aluminum composite outer skins over reinforced subframes. Given the sharp panel breaks and visible fasteners, this concept leans toward modular repairability rather than monolithic molding. Thermally, darker finishes absorb more solar radiation. To compensate, this design would require advanced insulation layers, potentially aerogel-infused sandwich panels, to maintain internal climate stability. The way light diffuses across the body is controlled and subdued. Edges catch illumination, surfaces remain muted. It reinforces the vehicle's architectural seriousness. The lighting system is highly structured. The front headlamp assembly integrates a sharp LED daytime running light signature, forming a geometric bracket around the primary projector unit. This is not decorative lighting, it is a hierarchy. Primary beam units are deeply inset, reducing vulnerability to debris impact. Secondary fog or terrain lights are housed lower within reinforced bumper structures. The roof-mounted LED light bar spans nearly the entire width of the cab. This suggests high-output off-road illumination capability, likely exceeding conventional road-legal luminosity. From a design language perspective, the lighting echoes modern tactical vehicle architecture. It communicates readiness rather than luxury flamboyance. Rear lighting, though partially obscured, appears vertically oriented. Vertical lighting elements enhance visibility in dust-heavy or snow-heavy environments by increasing sightline area. The windshield is expansive but steeply angled. Its integration into the A-pillars suggests reinforced framing capable of supporting the roof-mounted equipment load. Side windows are relatively modest in scale compared to traditional luxury motorhomes. This is a structural decision. Large glass expanses weaken torsional rigidity in off-road conditions. By limiting window size and embedding them within thick frames, this design prioritizes structural integrity over panoramic openness. Tint density appears moderate to heavy. This would assist in thermal insulation and privacy. Electrochromic glass technology would be a logical inclusion in a concept of this ambition. Variable opacity would allow occupants to adjust solar gain dynamically. Acoustically, the multi-pane construction would be essential. Given the tire profile and terrain focus, road noise mitigation becomes a critical comfort factor. The wheels are industrial in character. Multi-bolt heavy-duty hubs indicate significant payload capacity. Tire sidewalls are tall and aggressively lugged. These are not highway touring tires. They are optimized for deep sand, mud, and uneven rock surfaces. From a suspension perspective, independent systems would be preferable for articulation, though the visible axle thickness suggests heavy-duty solid axles. In a real-world production scenario, a hydraulic ride height adjustment system would be necessary to balance on-road stability with off-road articulation. The triple rear axle configuration significantly increases contact area. This distributes weight across terrain more effectively, reducing ground pressure. For long-distance mobility platforms, such distribution enhances both durability and safety margins. The roofline is populated with modular hardware. Low-profile racks, integrated lighting housings, and what appear to be communication modules suggest expedition-level autonomy. Solar integration is highly plausible here. The flat roof geometry would allow for extensive polar voltaic panel placement. However, solar alone would not sustain a vehicle of this scale. It would serve as a supplementary energy source for auxiliary systems rather than primary propulsion. Satellite connectivity modules could be embedded within the roof casing. Given the vehicle's intended archetype, long-range autonomous exploration, remote communication would be essential. The front fascia is bold, yet not ornamental. The grille is narrow and recessed, suggesting either minimal combustion cooling requirements or an electrified drivetrain architecture. If this were hydrogen-electric hybrid, Front cooling demands would be reduced compared to a conventional diesel powertrain. The bumper integrates recovery hooks and possibly a winch housing. This is functional readiness, not decorative aggression. Rear symmetry appears balanced, though the habitation box remains largely rectilinear. Airflow exit channels are subtle, likely integrated beneath the rear edge. What segment does this redefine? It challenges the conventional luxury motorhome by prioritizing structural autonomy over campground aesthetics. This concept leans more aerospace industrial than marine inspired. It feels engineered for remote research stations rather than leisure parks. The luxury positioning tier is ultra-exclusive expedition class, not defined by gold trim or marble surfaces, but by capability density and technological redundancy. The intended user archetype is someone who values sovereignty over spectacle, an explorer-technologist rather than a seasonal vacationer. From a maturity standpoint, the design is cohesive. It demonstrates internal logic between form and function. My first professional impression: this is a disciplined, structurally believable speculative platform. Its aggression is measured, its scale is justified, and its architectural integrity makes it one of the more convincing conceptual expedition motorhomes I have analyzed.
Given the exterior proportions and window placement, we can logically infer a highly compartmentalized interior structure. The roof height suggests a standing interior clearance exceeding 2.1 meters. Deck separation is unlikely in a full split-level sense, but a raised rear sleeping platform above utility storage is probable. Structural load paths would run longitudinally through reinforced floor beams, distributing habitation weight evenly across the triple rear axle system. Sleeping quarters would likely be positioned toward the rear third of the vehicle. This balances privacy with weight concentration over the multi-axle rear cluster. Thermally insulated composite walls would be essential. Given the matte exterior and potential solar absorption, high-performance insulation would prevent heat soak. The kitchen would need to adopt compact efficiency engineering. Induction-based cooking systems reduce open flame risks in remote environments. Water storage would likely exceed 400 liters to sustain multi-day autonomy. Logic must align with hybridized power storage, likely lithium iron phosphate battery arrays with a supplementary hydrogen fuel cell range extender. A wet bath configuration is plausible to conserve space. However, modular separation panels could create dual-function utility areas. Cockpit architecture appears commanding. Driver visibility is high due to the steep windshield and elevated seating position. Semi-autonomous highway assist would be feasible in a future forward context. Sensor placement along roof and grille areas suggests this direction. Off-grid autonomy calculations indicate that with optimized solar and hybrid systems, several days of stationary operation would be achievable without external input. Smart climate zoning would be mandatory. Large thermal mass structures require adaptive heating and cooling algorithms to prevent energy waste. From a future context reflection standpoint, what would be required to make this viable? Advancements in lightweight structural composites, higher density battery storage, integrated hydrogen distribution infrastructure. Current limitations primarily revolve around weight efficiency and energy density. Is this evolutionary or revolutionary? It is evolutionary in architecture, but revolutionary in scale and integration. and that is where its intrigue lies. It does not attempt fantasy, it attempts credibility. And in speculative design, credibility is the rarest luxury of all.